Welcome to Startup Hack. All right, so you want to build a machine to host AI in your home or office. Now, there's a tons of reasons for doing this. Maybe you want to learn about AI and running LLMs. Maybe you want to be able to build to start developing against. Or maybe you want to be able to run an internal application for your corporate needs without that staggering bill of the cloud CPUs. So I'm going to break it down for you today, explain why, explain costs and what kind of hardware you're going to need, and give you some stories about my journey in doing this and explain why I did what I have and what I learned along the way, which is a lot. So stick around because this will be really informative. It's super entertaining story time, even if all you want to do is just kind of learn more about it and you're not going to necessarily dive in to do it. I promise this will be educational and you'll come away knowing a lot more about AI, LLMs, and what it's going to take to run them. So let's dive in and get going. Welcome to Startup Hack. I'm Spencer Thompson. Here at Startup Hack, we love to train software developers in our licensed coding boot camps and build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming technology teams and products. All right, so you might be curious about this whole AI thing, how it works, or maybe you know a little bit about it, but you just want to dive in a little more and get your hands dirty with LLMs. Or maybe you're just a developer who wants to start building AI-powered stuff and without having to rely on someone else's servers or pushing your data into the cloud. Or if you're a business, you might want to run AI tools without getting hammered by these crazy cloud computing costs and getting nailed into these contracts. The other side of this that can be really important too is maybe you don't want to ship your data off to somewhere else when you have really sensitive data and you want to run it in a very secure environment. And so this allows you to start to learn to build for yourself. And today I'm going to teach you and walk you through the whole deal. I'll explain why it's worth it, give you the lowdown on how much it's going to cost, share with you some of my own experiences, including stuff that I've messed up, and tell you exactly why I went down this path, what I've learned along the way, and basically it's a tell-all story, so let's dive in here. All right, so one of the first things that I want to do is I want to jump over and go through a set of slides with you here, right? So these are some slides that kind of break down, and I picked out DeepSeek because it's all the rage right now, but it makes it really simple to see. It's also one of the more efficient, which is part of the reason it's all the rage, is one of the more efficient. So if you're going to be building at home, this is one of the ones you're going to want to be diving into. And once I explain some of the details here, then I'll kind of explain why it is DeepSeek that I chose to explain this with. All right. So when you talk about a model, you're going to talk about how many parameters it has. And in this case, DeepSeek comes with these following models. It comes with a 1.5, a 7 and an 8, a 14, 32, 70 billion, and the whopping 671 billion. Okay. Now, what is the GPU need that you're going to need for these? Because the GPU works together because LLMs are about pattern matching, right? It's about using vector math to do pattern matching so that you can process very quickly patterns to see where these patterns match and do the matching for these. And this is how all the words and all the word mappings is what's get trained. And this is why GPUs are really good at this, because if you think about what GPUs were built for, they were built to do vector graphics, vector math very quickly and to load models into that memory and to be able to perform against it very fast, right? And this is definitely an oversimplified explanation, but I'm trying to keep this high level and I've got a ton of material to get through. So as we look at this here, you're going to talk about how much VRAM or video RAM or the GPU RAM that your graphics card is going to have. You can get into doing this with CPUs, and I've read a ton about a lot of CPU builds for doing this. Ultimately, the GPUs are going to beat it every time, and this is why everybody's using GPUs. If you look at, the latest Grok 3 models that they built, they used over 200,000 H100s, and I'll talk about what that means here in a second. But they did this because that is the fastest and most performant way. Now, if you look at a 1.5 billion, you actually don't even need a GPU. This can run on pretty much any hardware. So I've done some previous videos, so make sure you like and subscribe and check out some of my previous videos because I've done this and shown that we could do this on a simple Raspberry Pi, right? And so you can run the 1.5 billion on a Raspberry Pi. So a computer the size of a credit card with 8 gigs of RAM, right? And you could even do it with less RAM actually, but this has a quad core processor and 4 gigs of RAM or 8 gigs of RAM. And this could run the 1.5 million pretty successfully. The problem with the 1.5 billion models, it's just not very accurate. And I'll show you a little bit more of this later. Then we start into getting to the 7 billion, 8 billion parameter. This can be run on a graphics card with 6 gigabytes of RAM. Now, most commonly, you're going to see 6 or 8 gigabytes of RAM. So any of those 8 and 6 gigabyte ranges, you can run these on. The 14 billion parameter, and the reason for this is because the size of these, and I'll show you these when we go over to Olama here in a minute. The size of these models need to be able to fit into the GPU RAM entirely. It can't use part of it. If even you starts to use part of it, then it has to use the CPU and not just the GPU. So the 14 billion model here can run against your graphics cards that have an 11 or 12 gigabytes of VRAM. Your 32 billion parameters is going to require 24 gigabytes. 70 billion can run on 48, comfortably run on 48. And these are generally the different step ups that you have of different graphics cards. Then you have your 671 billion, which is going to require 480 gigabytes of graphics. So now what does this mean? Let's break this down, the cost here a little bit more. So if you want to do this on a cloud computing, your H100 is pretty much what all the cloud computing models are going to be using to be able to run these LLMs. So this is an 80 gigabyte graphics card, and you can get a server that will run one of these. So you have a dedicated piece of hardware for you to be able to run this. On DigitalOcean, which seems to be one of the cheapest in the most reliable area that I've found. There may be some cheaper ones out there. I'm a big DigitalOcean fan. Shout out for DigitalOcean, who used it for a decade. $3.39 per hour. Now, that doesn't sound so bad at first. And yes, you could get into a scenario where you're spinning it up, spinning it down if you have workloads that only run during part of the day or something. But for most use cases, you're going to want these to be running pretty much 24/7 to make an application available when you need it. Now, if you're only doing this for development, you could spin it up and down when you're doing the development costs. But let's just run this. I'm going to run all these numbers just with the 24-hour cost, right? So that's $81 a day, $569 a week, and $2,500 a month to run one graphics card on one server. So you can see where this gets pretty pricey really quick. Your ROI has got to be greater than something of $2,500 a month just to be able to run one of these. So in some cases, this might be totally worth it. But like I said at the beginning, there's a lot of other reasons why you may not want to do this. So now if you want to get into hosting, so as you can see from that slide here, you can see that if you're running, pretty much this will run the DeepSeek. This cloud server would run pretty much all of these DeepSeek very, very efficiently. So you could actually run a 70 billion model running multiple different pipelines against it and run this very efficiently, right? You wouldn't be able to run the biggest model. In order to be able to run the biggest model, you would need to get into where you have at least 6 of these H100s. But generally with DigitalOcean, there was either choice for 1 or 8 GPU hosting. Now the GPU hosting with 8 is $24 per hour, which then totals up to $13,000 per week, which is a staggering $330,000 per month. There's very few companies and businesses that are going to be running at something that's going to be $300,000 per month. That is an absolutely overwhelming cost. Now, this is then where you lend into and say, well, why wouldn't I just purchase some of these myself? Okay, let's get into that. And that's exactly what the point of this video is I want to start to break down what kind of server costs you're going to need if you want to be able to run these various models. Now, again, as you look at these models here, the closer you get to the largest, the better scores you're going to get. So when you see all those benchmark scores about all the different AIs where Grok 3 is comparing against the latest Gemini 2.0 Flash and all of these, they're running against their largest models. It's always the largest models they're comparing against, right? And I'll show you some of the reasons that makes sense here in a minute. Now, so if you want to do some things, and if you, like, let's say you wanted to do the 1.5 billion parameter and you want to just run it really efficient, really fast to do this one thing, and you don't need crazy high accuracy, then you can just go grab any random $500 machine, just pretty much any PC that's laying around your office, slap Olama on top of it, put a 1.5, and about 20 bucks a month, you can run some costs. Your accuracy is going to be super low. Now, the 7 and 8 billion models is where you could actually start doing something worthwhile. The 1.5 model is pretty good for a party trick. That's about all it's really good for. Maybe if you want to tell some jokes or something silly like that. At the 7 billion, 8 billion parameter model, you can start to run something semi-interesting. And now this requires a $500 server. Your GPU costs are going to run pretty consistently. I can get an 8 gig card for $200 to $250. $200 if you buy something used or recertified, $250 if you're buying new. We might even call it $300. But your total all-in cost is between $700 and $800. Not bad, $20 a month, not a lot of hosting. Now, when you get to the 14 billion model, you're definitely, you're stepping up. Your GPU needs to be 16 gigs. Your cost of the GPU goes up more than even the machine at that point. You're really getting into the $750 range, was the cheapest I could really consistently find the cost of a 16 gig VRAM, to where your server cost is going to cost about $1,250. Okay. And your energy usage is going to go up slightly. So that bottom number is how much it costs energy usage wise to run. Now, when you start getting into models that get more efficient, 32 billion is when these models start getting really, really interesting. Before that, your accuracy is just really low. So 24 gig GPU, your GPU cost is about $1,250. Now, really your consumer grade GPUs are really pretty much limited at 24 gigs. You can't get really a whole lot of consumer grade GPUs with more than 24 gigs. So this is where you get into where you're still at single GPU usage, right? So a base server, still that PC sitting under your desk. You can slap a 24 gig card into it. It costs about $1,200 to $1,500, and you're looking at $1,700 to $2,000 for the cost of this. These cards are a little bit bigger, gonna definitely suck a little bit more electricity. You're looking about $30 a month. All right. The 70 billion model is actually the one where really, to me, the price point kind of cuts off and you start to really see the price point performance wise. And so the 70 billion model is really efficient, and you can get 2 of the 24 gig GPUs. So you're basically just taking these 2 24 gig GPUs and getting a machine that can run 2 of these. And there's lots of machines that can run 2 of these. It's not that uncommon. A pretty high-end gaming machine. Usually you want to pick up gaming machines because gaming machines frequently will have 2 PCI slots. Slap 2 of these 24 gigs cards in there. So you're running about $2,500 to $3,000 for consumer grade, 2 high-end consumer grade GPUs. Total cost is running between $3,000 and $4,000. Now, most businesses, this is something that you can still justify, and your ROI on this could be, turn back really quick. If you can justify, making 1 employee's worth of more efficiency out of your company, this is the kind of money that you could be spending, and a developer could be coding against this. So I'm going to be the rest of this project and the rest of the series that I'm going to be doing, because I'm going to be doing a series of these. So make sure you like and subscribe, because where I've done a lot about AI, I want to kind of keep moving forward with this DIY AI concept. So this, and go towards developers where you can start to develop against this without a huge bill. And this is what I'm really getting to today. So this cost is going to be roughly about $40 per month, $3,500. Now that's something that businesses could spend, and even a lot of personal people. If you want to start up, you're trying to start up an AI side hustle, trying to do something, improve a concept. This is still something that most people could scrounge up some money for. It's not exactly couch cushion money, but most businesses could. But then you see this huge jump from the 70 billion, and the next largest size is the 671 billion. And this is why people get into hosting in the cloud when you start getting into these large models. The amount of GPU you need for this is 480 gigabytes. This would mean you need at least 5 H100s, right? The H100s cost about $30,000 a piece, if you can even get your hands on them. Getting your hands on them is extremely difficult. Your base machine that you have underneath your desk, or even a higher end gaming machine, isn't going to cut it anymore. So this gaming machine you were going to spend $1,000 on here to get 2, PCI slots on, that gaming machine isn't going to cut it now, because now you got to get into something that has at least 5 PCI slots on it, right? Most of these are going to run between 6 and 8 PCI slots. For a server, you're going to usually need to get into dual CPU to be able to manage all that. And really just your GPU cost alone is $150,000. I'm not making this number up. You can go cost check these, and I can give you all the facts, and we can fact check these. But the rough reality of this is you're about $150,000 to $160,000 to get this server off the ground to even start. So running this is a staggering amount of thing. Now, can you run these? Yeah, you totally can, and there's some other ways you can, but it's going to be crazy slow to run something that would actually be production. And the interesting thing about this, the amount of power it's going to consume is going to be about $1,000 a month. So just the energy costs alone is going to be $1,000 a month. So when we go back to those very first slides and we start looking at why you would even run this H100 in the cloud at $2,500 a month, or why you would even contemplate something like eight H100s, you can see that even though it's $330,000 a month, like to just upfront $150,000 for the hardware is just staggering. And this is to build, and this would only run 1 model against it, and probably maybe not even run it efficiently. So that's kind of some of the hardware costs that I really wanted to go through, because that's going to frame a lot more of the story for why it is that I'm doing what I'm doing here. So I did a lot of different things. Recently, I tried to show how the Raspberry Pi has a Pi hat with an AI module. Well, it turns out that's actually only really good for image recognition. So it's AI doing image recognition, but it won't run against any of the LLMs. It won't run against any of those models because the whole purpose of those models is not just a speedy GPU, which is really all you were getting here. It's actually an NPU, a neural processing unit, which can process the vector math quickly, but it's still just reliant on the RAM and across the slow bus that it uses to go between the NPU. So really all this guy was good for, which I could grab the hardware here for you, but with that little hat on top of it, and that only cost about $80, so I wasn't out too much to test it here. But really all that was good for was some AI image recognition. Now that's pretty fancy and that's nifty, and it's pretty impressive actually for what it could do with that. So this is why I started to hunt down some other paths to where I wanted to get some other things. So this led me to what a lot of people have tried out there, and these are these NVIDIA Tesla cards. And so this is what they call the Tesla K80, and the Tesla K80 is one that has 24 gigs of graphics card. I actually took the cover off of it because one of the biggest problems is this is a server hosting card. So it's designed to actually have the server fan strapped here and have coolant blown across. So in order to put this into like a consumer grade PC, I had to buy these fans, this brick of fans, and basically slap these things together like this and tape them together just so it would stay cool. So, and I took that cover off to get it to run like that. Now I spent a ton of time, and I was going to actually do some videos of it, but the reality of the matter was getting the drivers to even load wasn't even stable. Once it was extremely slow. It saw it as two different graphics cards. So you still were doing some splitting of it because under the covers, the K80 is actually two 12 gig graphics cards. And the drivers, actually, the PCI bus for this is actually limited to a PCI 3. So this is essentially deprecated hardware that was really for some older machine learning that, unfortunately, because it'd be really nice if NVIDIA supported it, but the CUDA cores don't really support it anymore. So the software just really wasn't supporting this. And this, unfortunately, made this where I thought I could do something really fancy and beat the world and show everybody how we could beat these, because you can get these cards on eBay for about $80 to $100. And so I thought, oh man, 24 gigs of VRAM, like we're going to do some great stuff. In the end, what I ended up doing was just buying a regular RTX 3060 with 12 gigs of RAM. As soon as I put this into a Ubuntu desktop install, it just lit up and it worked. There wasn't any monkeying around with it. I could run Ollama. I could run any of the other simple studios, Llama CPP. All of it would support. The CUDA just literally installed as part of the Ubuntu installer. So the irony is that where I was trying to save a bunch of money to run this, and ultimately I bill out a lot of my time and hours, hourly for consulting, this actually probably burned me a couple of days, man days worth of work to try to figure this out, that essentially I was better off to just spend a less than $500 difference and actually get a good 12 gig graphics card that could run. Now, I just did the 12 gig for right now. Probably grab a 24 gig here pretty soon, but I want to keep going with this 12 gig because I want to be able to show and demonstrate to you guys what you can do with a 12 gig card. So we're going to really break this down today because I want to go through this and show you guys exactly what I have running here. So I'm going to jump over into some real world examples. We're going to run through them. I'm definitely going to do some future with wrapping different code around this. So we're going to wrap some .NET code around this, but I want to show you guys then what I have running just literally in a server that's sitting down underneath here. And by server, I'll explain to you a little bit more about what that is 1 second here. All right, so this is my server here. Now, when I say you can literally grab like any computer out there, I'm really not kidding. Now, granted, this was a powerful server in its day, 12, 13 years ago, right? So this is an AMD FX 8350. So to put this into perspective, this processor was launched in October of 2012, right? So 13 years ago now, almost. It does run 8 cores with 8 threads. So, it's the socket AM3. So this is pretty old. It's 4 gigahertz. But the CPU, what I'm trying to show you guys here is the CPU isn't going to really matter like much because we're not really even going to use the CPU here. So this is just an old 8-core. These old AMDs were super big space heaters, right? Because it was the FX series, which really just, stood for space heater. And this guy then has 16 gigs of RAM, and then has that RTX 3060 onto it that you can see. And so Find that one for you here. But it's just the RTX 3060 with 12 gigs of RAM. So just kind of want to explain to you guys the hardware I have. I don't have anything crazy. This was literally a server or machine that's been kicking around in my room for a long time with a very consumer grade graphics card that I just bought off of eBay as a used card for like $250. So, I mean, I had the machine, but let's say you can buy an old ratty computer like this for $200 to $300, $250 for the GPU. I'm about $500 in on the hardware here, right? So just trying to kind of explain to you guys where we're at. Now, given that, we're going to kind of take a look here and look at what models of Ollama that I have running here. Okay, so we're going to show you which models I've already loaded these up ahead of time because the downloading takes a little while, but it's not super hard. And I'm going to show you how we're doing this here. So I can say Ollama list. These are the models that I've loaded up for you. Now, I'm going to demonstrate for you what the 1.5, 7 and 8, 7 and 8 have very, very little difference. 8's just a lot more efficient, but these are these sizes that I was talking about. And so pretty simply put, you can look at the size of the model and say, hey, look, I could run pretty comfortably with my 12 gig card up to the 9 gigabytes of this, and it'll run really comfortably. And I'll show you exactly what this means here as we run this. So let's start off here with I'm going to kind of skip. Well, let's do the Ollama 1.5 here, right? So I'm going to run the Ollama 1.5. So we're going to run the DeepSeek 1.5 here. So I'm going to paste that in. You can see that they'll run. It takes a second to load here. And once it loads up, then you can see that loaded up pretty quick. Now I'm going to toggle over to another window here. I'm going to have two SSH windows open really quick. Now on this SSH window, I want to show you as we're running here, you can run Ollama PS. This is going to actually show you where your model is running, and you're going to see this because this will get really interesting as we go a little bit forward here, right? So you can see that it actually is running 100% on the GPU. Size is only 2 gigabytes, right? Because it's not taking up much here. So, right, it says 1.1 here, but the actual size that it takes onto the RAM is just slightly larger than what your model size is. Okay, about 1.2 times is what you usually run at here. So we can see that the size is 2 gigs and it's running all on the GPU. So if I ask our DeepSeek here and I say, why is the, oops, and I just realized that what I did here. So one of the first things is when you're doing this, if you run with a dash verbose, what it's going to actually do is it will actually help you. Now, you notice that loaded up a lot faster than the second time. It's actually already loaded up into memory. And so unless you load a different model, it's going to actually be sitting there running in the background. So if I say, why is the sky blue? This verbose command here at the end is going to give us a bunch of stats, which are super helpful, right? So you can see super quick, right? Running right around, 4.5 tokens per second. The eval tokens here, the count there was quick. The eval rate here, 117 tokens per second. So, the total eval rate, which is this bottom number here. So way high, right? Now, so plenty of power for being able to do that. So let's bump this up a little bit. And I'm just going to skip the 7 billion because the 7 billion and 8 billion really run pretty close to each other. So let's run the 8 billion model here. Again, larger size of the model, more work it's going to do to be moving that from disk over to the VRAM as it loads. And so again, faster cards are going to load faster and even a faster system. This is actually where system speed on startup is going to make a big difference. Now, if I say, why is the sky blue? And I forgot the question mark. We'll see if it makes a difference. So you can see it's still pretty zippy and pretty responsive, right? And so we're definitely within a reasonable rate that you can see something pretty fast. Still running at 50 tokens per second. Pretty quick here, right? So very impressive enough for something that we need to be doing here. Oh, and on the other side, let's go check what our GPU looks like here, right? So now this is actually running both here at the second, so I may have to actually kill off this first one, because we will top out here. But you can see that even with the 8 billion model, it runs very efficiently. And this is one of the things that DeepSeek is really good at. And part of the reasons it's kind of rocked the AI world a little bit is it's running at 6.9 gigs in memory, right? So it's running that, and it's running 100% still on the CPU. Now this is actually running both models right at the moment. So you can see that it's still even running that snappy and with that kind of performance, which, you can see here, even at those reasonable rates. So now I'm going to kill off both of these really quick and we'll restart this. All right, now what I did is I ran Olama stop on each of these, and now as I toggle back over to this other model, this other window where we were tracking the PS, you can see now there's no Olama models running here, right? So we're still wide open. So now let's jump in and get back to, we're going to start getting to some of our models that are going to push this just a little bit here. Now, where I'm actually getting these commands from is if you're on Olama and you go to this models tab, you go to the DeepSeek model here, right? So on the DeepSeek model, you can go here and you can actually pick which one of these parameters. And it's going to tell you all about these different parameters here, right? So you can, or these different parameter sizes. Now, if we run this and it's even telling us, to do start and stop, right? But I can actually copy this command too. So if I switch over to, so we're going to move up to this 14 billion model now, right? So as I move to this 14 billion, I can copy that. We can hop back over to our window here and I can run that. Now, if it hasn't already downloaded, at this point, you're going to see it do all the downloading, right? And so it's going to be downloading all of those models. Now, the 14 billion is starting to really push the size of the GPU. So if we look at this now, we can see, hey, look, it's at 11 gigs. So we're at a 12 gig graphics card here. So we're definitely pushing our boundaries, but it is still 100% running on the GPU. So we should still get a pretty good performance from this, but you can see that the load time is taking quite a bit longer. So we're going to let this guy load here, and it is going to take just a minute. So, okay, that just loaded. So I'm keeping this real time for y'all, keeping this real and raw, folks. So now, why is the sky blue? Definitely see that this is taking a little bit longer. You're getting a little more think time. You get that think there, right? So, and again, as you step up, you're going to get more reasoning, which is that think time on those models. And that's part of how they get more efficient. But we see as we get to the end of this, it's still a pretty good response time though, right? You can still do this, but the accuracy of this is far better than what we were getting. See, like, look at this. These were just, birds flying, right? Like, this doesn't even make sense. I said, why is the sky blue? And it's talking about birds flying and fog and smoke, right? Like, yeah, birds such as robin known to, like, what? That doesn't even make sense, right? So the 1.5 billion model accuracy doesn't even really make sense. But as we start getting up to this 14 billion parameter, the accuracy of these responses get way more. Oops, we forgot to run it in verbose mode. So we're going to hop out here, and I'm going to actually speed this up for y'all. So let's try that again. Why is the sky blue? And now you can see that this is running, still running pretty quick, and especially because we had just run this again, it's going to become more efficient. This is part of how models work. This is part of like why training. Now you can see that our token evaluation rate is definitely way lower, right? Where, our eval rate is 360 tokens per second. The total eval rate is right around 30 tokens per second. So definitely running a lot slower here than we were seeing before, right? So this is, still definitely doable. So with your 12 gig graphics card, I really kind of found that, oh, and we can check here, so yeah, this is still running, totally GPU. We haven't touched the CPU yet, right? And especially on an older piece of hardware like this, if you want to be able to fall back and use part of your CPU and the RAM and the GPU, it is possible. And we're going to see that here on this next step up. But ultimately, especially on an older piece of hardware like that, we're definitely going to see this guy slow down. So let's live crazy here. And we're going to talk about this one here. And this guy has a 20 gig size for its for the model here. So let's get out of this one. And again, I downloaded all these before. The download, because these download sizes aren't trivial. And I'm going to add verbose. Now, this one I am going to speed up because there's no way you're going to want to wait. So I'm going to kind of watch my clock here, and we'll tell you exactly how long this guy took to load. All right, so that did take a full 2 minutes for that to start up. So that was quite a while, right? So if I now say, why is the sky blue? Now, I don't even have to guess on this one. As soon as I hit enter, it's going to start running. But you can see the think time on this one is really long. So, and I'm going to show you partly why. So see, that's going really slow. See, okay, I'm trying to figure, like, really crunching here. So as I get over and we look at this one now, see, now we have just this 32 gig model running, right? And this 32 billion input model, and it's running at 22 gigs. Now, my graphics card is 12 gigs here, right? So we're running at 45% CPU and 55% GPU. So that's part of the reason. And again, on super old hardware like this dude's crunching. he's having a rough day today, right? So I'm going to let this guy finish out, and I'll show you at the end what the stats look like. But this is obviously not something that you could even really want to do even in development, let alone in any kind of production app for you to develop against. All right, so I'm actually going to be super authentic here. This old machine that I had actually overheated. It actually overheated and crashed trying to run this, because the problem is that with the GPU pulling, and I'm pretty sure it has enough power. I don't think the power supply is the problem. It's a 700 watt power supply, but I actually think there's some cooling problems. I think there may be a problem with it has an super old liquid cooler, and I think the CPU actually like overheated and died here. And so the computer actually crashed, just rebooted and came back up after a minute or so, but it had taken already 5 minutes to get this to this point. So needless to say that your whatever the resulting token was, what we're really running into here is this story right here. I think a lot of what you have here is this story. This is the story here that shows that your 1.5 model can run on 2 gigs, 100% GPU. Your 8 gig model, or 8 billion model, 6.8 gigs, or just under 7 gigs. And this was even actually with both of them running, right? So it was actually running the 8 and the 1.5 here, and it could actually still do it. So it's actually kind of an interesting thing too, because you could actually run 2 different processing pipelines through these. When you get to the 14 billion, your 12 gig graphics card could still handle this. And I know you can run 2 different pipelines of this because I've done it, and we'll show some of these in future videos. So make sure you like and subscribe, because here at Startup Hack, we love to train software developers as well as to build custom software solutions, including a lot of AI solutions. One of the big reasons that we've built AI solutions here, and I'll tell you a little bit more about this here as I finish my sum up here, but of why we're doing some of our DIY kits here. But ultimately, when you start getting into the 32, this is where my server started to fall over. Now, you can absolutely fit this 22 if you get a 24 gig graphics card. For this channel, I just don't get enough of you guys following yet. I need more people to follow me. And once I do, I can start buying some cooler hardware and do some cooler stuff. But for right now, my budget's pretty small. And part of this is to be showing you that I'm running on a shoestring budget here, right? And we're being really real. So you can see how this starts to run, and even to the point where the thing literally fell over. So this kind of goes to show but for under $1,000, you could build something that could run on these 14 billion models. So if you were doing something that is running and you can get it really repeatable, and you get it to where you can train these models and get it to where you can do these things in a way that is super repeatable, then there's a lot that you can do with a machine for this. And so part of the reason that we built this is because we run AskMany.ai. It's one of the brands that we've built here at Startup Hack. We also do a lot of other .NET as well as AI code consulting for folks. And so we have a lot of different clients that do a lot of different projects, some big, some small. And as we've worked with different .NET and different AI projects here, we've built a lot of these systems where we've built these custom AI machines. And the nice part about it is for, like I said, for between $1,000 to $4,000, kind of depending on your need here, you can get to where you can build your own AI machine. And I'm going to do a future video here, so make sure you like and subscribe, because I'm going to do one about showing you how we do a .NET wrapper around these to be able to take your .NET code and to be able to run a very simple agent that can do a specific task for you. So we're going to show you some of this in the future, so you definitely want to make sure you like and subscribe, because we also love to train software developers, because we are a licensed vocational school. So we love to train people here, and that's what I'm going to end up with here. It's been great to show you all this. And so obviously the best compliment you can always give me is to leave a comment down below. Let me know if you liked the video. Let me know things you'd like to see me try, and we will catch you guys next time.
Want to become a software developer but don't want to spend 4 years in college and rack up massive student loan debts? Think you need technical expertise to get started? Welcome to Startup Hack, a better way to start your software career without student loans and years without income. One-on-one tutoring is included, so you never get stuck and have guidance through the whole process. No technical experience is necessary. Learn at your own pace and in your own space. Startup Hack has worked with local state agencies in your area to make it so that qualifying students can get the program costs covered entirely, and students can start earning while they learn.
Startup Hack's .NET Coding Bootcamp was a game changer for my career. As someone with no prior programming experience, I was initially intimidated by the idea of learning to code, but the instructors at Startup Hack broke down complex concepts into easy to understand lessons and provided hands-on projects that really cemented my understanding. The curriculum was comprehensive and up to date and got me ready for my first job. What really set Startup Hack apart was the focus on practical, real-world skills. Thanks to Startup Hack, I landed my dream job as a .NET developer within weeks of graduating. I went from knowing nothing about code to building professional-grade web applications in just a few intense months. If you're looking to break into .NET development or level up your coding skills, I cannot recommend Startup Hack enough.
Complete our 3-month coding bootcamp, gain hands-on experience, and land a paid internship. With 2 years of experience, on average, our graduates are making over $80,000 per year. The 3-month program includes technologies from Microsoft, Google, and Facebook. No debt, just a quick path to earning. Check out startuphack.com to code your future and start today.